Okay, so here's our video notes that are going to go along with this unit. Last unit was periodic table. It was pretty easy cheesy. We were able to get through that one quickly. We didn't do video notes, but all last semester we did do video notes. Yes, we're still going to have our traditional notes, but especially now we're going to get to some stuff that some of us just do not know. And the best way to help you out is to maybe listen to it and hear it first with the video notes, and then we'll go over our traditional notes in class, because there are just some things that you know that you don't know, and there's some things that you don't know that you don't know. So right now with this notes, you're going to hear quite a few things that you did not know that you didn't know. Okay, it's going to be new information for some of you. All right, so let's go ahead and begin. We've got all of our units. You should have your notes there printed out in front of you, ready to go. Let me hit play here so we can start this video.
How are positive and negative ions like the positive and negative ends of two magnets? Some atoms can fill their outermost energy levels by gaining or losing electrons. When an atom loses electrons, it becomes a positive ion. When an atom gains electrons, it becomes a negative ion. For example, a sodium atom loses one valence electron, while the chlorine atom gains the same electron. This occurs because atoms tend to gain or lose electrons to acquire a stable outer electron level, which has 8 valence electrons, called an octet. The sodium and the chloride now have opposite charges, and atoms with opposite charges are attracted to each other. This attraction causes an ionic bond. When an atom loses electrons, the number of protons remains unchanged, so the atom has more protons than electrons. This causes the atom to become an ion with a positive charge. A cation is an ion that has a positive charge. Metals lose valence electrons to become cations. When an atom gains electrons, the number of protons remains unchanged, so the atom has more electrons than protons. This causes the atom to become an ion with a negative charge. An anion is an ion that has a negative charge. Nonmetals gain electrons to become anions. An ionic bond often joins a metal to a nonmetal. Metals lose electrons to become cations, and nonmetals gain electrons to become anions. Atoms in group 1, or 1a, donate one electron to become 1+ ions. Atoms in group 17, or 7a, accept one electron to become 1- ions. Atoms in group 2, or 2a, donate 2 electrons to become 2+ ions. Atoms in group 16, or 6a, accept 2 electrons to become 2- ions. Atoms in group 13, or 3a, lose 3 electrons to become 3+ ions. Atoms in group 15, or 5a, gain 3 electrons to become 3- ions. Atoms in group 14, or 4a, usually don't form ions. Atoms in group 18, or 8a, the noble gases, don't form ions because their outer electron level is full. Ionic compounds have no overall charge. The total number of positive charges must equal the total number of negative charges. Lithium is an element that forms ions with a 1+ charge by losing its 1 valence electron. Chlorine is an element that forms ions with a 1- charge by gaining a valence electron. In order to form an ionic compound with no overall charge, 1 lithium ion would be required to bond with 1 chloride ion and form lithium chloride. The formula for lithium chloride is LiCl. What if calcium were to form an ionic compound with chlorine? Calcium is an element that forms ions that have a 2+ charge, since it loses 2 valence electrons to become stable. Because chlorine only needs one valence electron to become stable, calcium will donate one of its two valence electrons to one chlorine atom, and its other valence electron to another chlorine atom. The calcium ion and the two chloride ions bond to form calcium chloride. The formula for calcium chloride is CaCl2. What if aluminum were to form an ionic compound with chlorine? Aluminum is an element that must donate its 3 valence electrons to form an ion with a 3+ charge. In order to form an ionic compound, 3 chlorine atoms are required, because aluminum must donate each of its 3 valence electrons to a separate chlorine atom. What if aluminum were to form an ionic compound with oxygen? Oxygen is an element that forms ions with a 2- charge. In order to form an ionic compound with no overall charge, 2 aluminum ions and 3 oxygen ions would be required to bond and form aluminum oxide. The formula for aluminum oxide is Al2O3. Electron dot structures can be used to represent ionic bonds. An electron dot structure is made up of an element symbol with surrounding dots. The symbol represents the nucleus and inner electrons, while the dots represent an element's valence electrons. Remember that group numbers correspond to the number of dots in the element's dot structure. So elements in group 1A, like lithium, have 1 dot, and elements in group 7A, like chlorine, have 7 dots. This Lewis dot structure shows how lithium donates its 1 valence electron to chlorine in order to form the ionic compound lithium chloride.
Let's go ahead and go to the next one. Let's exit out of here. That was ionic bonding. Now let's get to naming ionic compounds. Again, I know some of this stuff is just going to be new to you and you're not sure what this is, but let's go ahead and listen to it now. Write your notes down, go back and reread them because we will work on our class notes together as well.
In the 1940s, lithium chloride was marketed by some companies as an acceptable substitute for table salt, or sodium chloride. However, after investigating deaths related to the intake of lithium chloride, the Food and Drug Administration soon classified lithium chloride as a drug instead of as a special dietary food. How are the names of the compounds lithium chloride and sodium chloride similar? How are they different? Ionic compounds are formed from metals and nonmetals. Metals are elements that are to the left of the stair-step line on the periodic table. Nonmetals are elements that are to the right of the stair-step line on the periodic table. Metals tend to lose valence electrons, and nonmetals tend to gain valence electrons. When metals lose electrons, they form cations. A cation is a positively charged ion that is formed when an atom loses electrons. When nonmetals gain electrons, they form anions. An anion is a negatively charged ion that is formed whenever an atom gains electrons. An ionic compound is a substance that is formed by the attraction between oppositely charged cations, metals, and anions, nonmetals. Because both the cation, metal, and anion, nonmetal, share a role in the formation of an ionic compound, the name of both ions is found in the name of the ionic compound. To name an ionic compound, first give the name of the cation, metal, followed by the name of the anion, nonmetal. The cation is always named first. The names of cations are similar to the names of the atoms from which they are formed. If a potassium atom loses 1 electron, then the resulting ion is called a potassium ion K+. If a magnesium atom loses 2 electrons, then it becomes a magnesium ion Mg2+. Look at the periodic table. Notice how elements in group 1 must lose 1 electron in order to become ions with a 1+ charge. Elements in group 2 must lose 2 electrons in order to become ions with a 2+ charge. Elements in group 3 must lose 3 electrons in order to become ions with a 3+ charge. The metals in group 14 form cations with various charges. This chart lists the names of some common cations and their charges. The name of an anion is similar to the atom from which it is formed. The difference between the name of the atom and the name of the anion is the suffix. The name of an anion ends in "ide." Fluorine is the atom that forms the fluoride ion. The fluorine atom gains 1 electron to become a fluoride ion F-. An oxygen atom gains 2 electrons to become an oxide ion O2-. A nitrogen atom gains 3 electrons to become a nitride ion N3-. The periodic table shows that elements in group 15 form ions with a 3- charge. Elements in group 16 form ions with a 2- charge, and elements in group 17 form ions with a 1- charge. The noble gases don't form ions. This chart gives a list of some common anions and their charges. Table salt is a common ionic compound. The chemical name for table salt is sodium chloride. The chemical name indicates that table salt is an ionic compound, made up of a sodium ion, which is a cation, and a chloride ion, which is an anion. Sodium chloride crystals are made up of a large group of positive sodium ions and negative chloride ions. The ions form a regular pattern of alternating cations and anions that are held together by the strong electrical or electrostatic attraction between the ions. Many of the transition metals can form a variety of ions with different charges. For example, copper can form 2 ions, one with a charge of 1+ and another with a charge of 2+. These ions are both copper ions, but the different charges make each react differently when forming compounds. To name the 2 different ions, scientists use a Roman numeral equal to the charge. Copper 1+ is copper 1, and copper 2+ is copper 2. If your teacher asked you to go into the lab and retrieve some copper chloride, you should first ask, which one, copper 1 or copper 2? The 2 different copper ions for 2 different copper chloride compounds. This chart gives a list of some common transition metal cations.
Let's go ahead and keep going forward to the next one. Next one is going to be writing ionic formulas.
What are the advantages of representing the name of an ionic compound with a formula? Ionic compounds are made up of a repeating pattern of cations and anions. Formulas for ionic compounds are just an expression of a ratio, the ratio of positive ions to negative ions. A formula unit represents the simplest or reduced ratio of positive ions to negative ions. The formula unit for sodium chloride is NaCl, because the ions are arranged in a repeating pattern of 1 sodium ion for every 1 chloride ion. In an ionic compound formula, the symbol for the cation is always written first, and the symbol for the anion is always written second. A subscript indicates the number of cations or anions in the compound. If a symbol does not have a subscript, then the subscript is assumed to be 1. Ionic compounds are neutral, so the total positive charges must equal the total negative charges. Recall that elements in group 1 form 1+ ions. Group 2 forms 2+ ions. Group 13 forms 3+ ions. The metals tin, Sn, and lead, Pb, in group 14 can form 4+ ions. Group 15 forms 3- ions. Group 16 forms 2- ions. And group 17 forms 1- ions. Calcium has a 2+ charge. In order to form an ionic compound with 0 charge, it bonds with 2 chloride ions that each have a 1- charge. What is the formula for an ionic compound that is formed between sodium and oxygen? Sodium is in group 1, so it forms ions with a 1+ charge. Oxygen is in group 16, so it forms ions with a 2- charge. The cation is written first, so the compound will be sodium oxide. To get the correct subscripts, you can drop the positive and negative signs and crisscross the charge numbers so that they become the subscripts of the chemical formula. An ionic compound formed between sodium and oxygen must have 2 sodium ions and 1 oxygen ion. Crisscrossing the numbers balances the charges to form a neutral compound. In order to form a neutral ionic compound, 2 sodium ions, each with a 1+ charge, balance the 1 oxide ion that has a 2- charge. Notice that oxygen has no subscript in the formula, because there is only 1 oxygen ion in the formula unit. Remember that many transition metals can form a variety of ions with different charges. When naming an ionic compound that contains a transition metal, scientists use a Roman numeral after the name of the transition metal to indicate the charge. Iron 3 oxide contains iron 3 ions that have a 3+ charge and oxide ions that have a 2- charge. Crisscrossing the charge numbers gives the formula for iron 3 oxide, Fe2O3. Many ionic compounds contain polyatomic ions. A polyatomic ion is a group of covalently bonded atoms that act as a unit and have a charge. The chart lists the name, formula, and charge of some common polyatomic ions. The rules for writing an ionic formula containing a polyatomic ion are the same as the rules for the formulas of other ionic compounds. However, if a subscript must be placed on a polyatomic ion, then the polyatomic ion should be placed inside parentheses, and the subscript should be placed outside of the parentheses.
Well, let's go to the next one, and we're going to get to covalent bonding.
A single covalent bond is the sharing of 2, or 1 pair of, electrons between 2 atoms. A double covalent bond is the sharing of 4, or 2 pairs of, electrons. Based on this information, what do you predict a triple covalent bond is? If the outermost energy level of an atom is full, then the atom attains the stability of a noble gas. Hydrogen has 1 valence electron, so it needs 1 more electron to attain the stable noble gas configuration of helium. Recall that the Roman numerals of the main group elements are equal to the number of valence electrons in each group. For example, nitrogen has 5 valence electrons and needs 3 more to attain the noble gas configuration of neon. Fluorine has 7 valence electrons and needs 1 more to become stable. Some atoms can fill their outermost energy levels by sharing electrons. This is called a covalent bond. Hydrogen atoms form a covalent bond when they share electrons. By sharing electrons, each hydrogen atom has 2 electrons orbiting its nucleus. This is the maximum number for the first energy level, so each hydrogen atom is complete or stable. There are 7 elements that form molecules when 2 atoms of the same element share electrons. These molecules are known as diatomic molecules. The periodic table shows the 7 elements that form diatomic molecules. The electron dot structure for methane, CH4, shows the covalent bonds between carbon and hydrogen. Each hydrogen shares 2 electrons, while the carbon atom shares 8 electrons. When the electrons are shared equally between 2 atoms, the bond is called a nonpolar covalent bond. Imagine that your little brother is playing with 4 army men, and his friend Chris brings 4 army men over to your house. The two can then play with 8 army men together. Likewise, a nonpolar covalent bond involves equal sharing of electrons. Sometimes the shared electrons between 2 atoms are more attracted to one atom than the other. When this happens, the bond is called a polar covalent bond. Imagine your brother and Chris together have 8 army men, but Chris only lets your brother move 3 of the 8 army men. They're sharing the army men, but one gets to play with them more than the other does. Likewise, a polar covalent bond involves unequal sharing of electrons. Every atom has a specific ability to attract electrons. Electronegativity is the ability of an atom to attract electrons to it while bonded. Electrons are more attracted to atoms with higher electronegativities. The most electronegative atom on the periodic table is fluorine, and the least electronegative atom is francium. To determine if a bond between 2 atoms is polar covalent or nonpolar covalent, take the difference of the 2 atoms' electronegativities. If the difference is 0, then the bond is most likely nonpolar covalent. If the difference is less than 0.4, then the bond is mostly covalent, and the electrons are shared somewhat equally. If the difference is between 0.4 and 1.7, then the bond is polar covalent. If the electronegativity difference between 2 atoms is greater than 1.7, then the electrons will become so attracted to one of the atoms that they transfer to that atom completely. This type of bond is an ionic bond. An electronegativity difference of 1.7 is not entirely ionic, but is actually 50% ionic and 50% covalent. As the electronegativity difference increases from 1.7, the bond is considered to be more ionic. The values given in the table are to be used as a guide to classify bonds. Water is formed by polar covalent bonds. Because oxygen is more electronegative than hydrogen, the shared electrons spend more time around the oxygen and less time around the hydrogens. This gives the oxygen end a slightly negative charge and the hydrogen end a slightly positive charge. The lowercase Greek letter delta is often used to indicate the end of a molecule that has a partial charge. Notice that a delta with a superscript plus sign is placed near both of the hydrogen atoms of the water molecule to indicate the end that has a slightly positive charge. A delta with a superscript minus sign is placed by the oxygen atom to indicate the end that has a slightly negative charge. A polar molecule has a positive pole and a negative pole, like a magnet has positive and negative poles. The polarity of the water molecule gives it unique properties. Biomolecules such as carbohydrates, proteins, lipids, and nucleic acids all have covalent bonds holding them together. What information can you infer about a shape from its name? What can you infer about a covalent compound called phosphorus pentachloride? A covalent compound is a substance that exists as a collection of identical molecules. These molecules are formed when atoms of different elements share electrons. The rules for naming covalent compounds consisting of two elements are not the same as the rules for naming ionic compounds. This covalent compound made up of nitrogen and oxygen atoms is not nitrogen oxide. Instead, covalent compounds made from two elements are named using prefixes that denote how many atoms of each element are in the molecule. The chart shows prefixes for the numbers 1 through 10. When naming a covalent compound, the element that is the farthest left on the periodic table is listed first. If carbon and bromine are the two elements in the compound, then carbon is named first. The only exception to this rule occurs when oxygen forms a covalent bond with a halogen. In that case, the halogen is named first. If oxygen and bromine are the two elements in a compound, then bromine is named first because it is a halogen forming a covalent bond with oxygen. If there is only one atom per molecule of the first element named, then the prefix mono is dropped. The second element that is named in the compound ends in the suffix "ide." For example, one atom of carbon and one atom of oxygen bond to form a molecule of carbon monoxide. How would you name the covalent compound given by the chemical formula N2O4? Begin with the order of the elements in the name. Nitrogen is given first in the chemical formula because it is farther left on the periodic table than oxygen. The subscripts that follow each element symbol in the chemical formula show that there are 2 nitrogen atoms and 4 oxygen atoms in a molecule of N2O4. To name this covalent compound, we add the appropriate prefixes to the element names, and oxygen changes to oxide. The name of the covalent compound is dinitrogen tetroxide. Notice that the name dinitrogen tetroxide does not contain the A from the tetra prefix. When prefixes ending in A or O are added to oxygen, the A or the O is usually dropped. The I in the di and tri prefixes is never dropped. How would you name the covalent compound BF3? This molecule is made up of 1 boron atom and 3 fluorine atoms. Boron is named before fluorine because boron is farther left on the periodic table. There is only 1 atom of boron, the first element named, so the prefix mono can be dropped. Therefore, the name of the covalent compound is boron trifluoride. The names of some common covalent compounds don't follow the traditional rules for naming covalent compounds. This table lists the common name for some of those compounds. Sometimes, 2 atoms of the same element will share electrons and covalently bond to form a molecule. These molecules are known as diatomic molecules. The names of these compounds are typically the same as the name of the element that makes up the molecule. A diatomic hydrogen molecule is simply called hydrogen. Hydrogen, nitrogen, oxygen, and all the halogens do not exist as single atoms. They always double up to form diatomic molecules. Notice that all of the elements that double up to form diatomic molecules, excluding hydrogen, form the shape of the number 7 on the periodic table. What are some similarities and differences between these 2 molecules? A covalent compound is a collection of identical molecules formed when atoms of 2 or more nonmetals share electrons. The molecular formula for a covalent compound represents the exact number of atoms of each element that are present in one molecule of the compound. This is different from the formula for an ionic compound, which is always a reduced ratio of positive to negative ions. In a covalent compound formula, the symbol of the first named element is written first, and the symbol of the second named element is written second. Each symbol is followed by a subscript that represents the actual number of those atoms that are present in the molecule. Notice that trifluoride begins with the prefix tri, and its subscript is 3. If a symbol does not have a subscript, then the subscript is assumed to be 1. The prefixes found in the name of a covalent compound indicate how many atoms of each element are present in the molecule. Each prefix can be translated into a subscript written to the right of the element symbol. This chart gives prefixes that are used in naming covalent compounds and the number that each prefix represents. The prefix mono is dropped in the first named element if there is only one atom of that element present in the compound. What is the chemical formula for selenium hexafluoride? There is no prefix preceding selenium, which indicates that there is only one selenium atom per molecule. The prefix hexa in hexafluoride indicates that there are 6 fluorine atoms per molecule. Therefore, the formula for selenium hexafluoride is SeF6. What is the chemical formula for diboron tetrachloride? The di prefix in diboron indicates that there are 2 boron atoms per molecule, and the tetra prefix in tetrachloride indicates that there are 4 atoms of chlorine per molecule. The formula for diboron tetrachloride is B2Cl4. What is the name of the covalent compound given by the formula P4S3? The subscripts indicate that there are 4 phosphorus atoms and 3 sulfur atoms in each molecule. Tetra is the prefix used to indicate 4 atoms of a particular element in each molecule, and tri is the prefix used to indicate 3 atoms. Therefore, the name of the compound is tetraphosphorus trisulfide. Remember that the "ide" suffix is always added to the second element named in a covalent compound. Several covalent compounds are better known by a common name instead of the traditional molecular compound name. We commonly refer to H2O as water and C2H6O as ethanol. This table lists chemical formulas and common names for some covalent compounds.